Earth gives us raw materials, but rarely in a form we can actually use. To turn dirt and rock into the beams holding up your roof, you have to subject those natural resources to extreme heat and heavy machinery. This transformation is known as a secondary activity. It is the process of taking something directly from nature, the primary sector, and running it through a factory to change its form, making it drastically more useful to people. A raw cotton ball plucked from a field has almost no utility on its own, but run it through a textile mill to spin, weave, and dye it, and you get acres of fabric ready to be cut into clothing. This is value addition, where the manufacturing process itself creates the worth of the final product. But those manufacturing plants aren't placed on a map at random. Their location is dictated by a set of specific requirements, from the availability of power and labor to the proximity of the market. Understanding these requirements allows us to see our industrial landscape for what it actually is, a map of calculated decisions where geography and economics intersect. The first variable in this calculation is the raw material itself. An industry's placement depends on what it processes, whether it relies on agriculture, minerals extracted from the ground, resources from the ocean, or timber from a forest. Then there is scale. If an artisan is weaving a basket by hand using local bamboo, it is a cottage industry. These are small-scale operations that require very little capital. Large-scale industries, by contrast, require massive investments in technology and thousands of laborers to produce a high volume of goods. We also have to consider who owns the facility. Some, like the plants manufacturing defense equipment for Hindustan Aeronautics Limited, are public sector industries. These are entirely owned and operated by the government. Compare that to a milk tanker entering an Amul dairy plant. This is a cooperative sector industry, where the farmers who supply the raw milk are the same individuals who own and operate the enterprise. These factors, raw material, size, and ownership, are the primary categories that define an industry. They establish the baseline needs that a company must satisfy before it even breaks ground. Every factory functions as a system. It takes in inputs, like land and power, processes them, and releases outputs. But in the iron and steel industry, this is a feeder industry. The finished steel loops back around as raw material for other businesses. Because of this massive scale, placement is critical. In 1907, when Tata Iron and Steel was being established, the choice of a specific village in India was based on an exhaustive search for the right geographic conditions. This map shows why Jamshedpur was the ideal site. It sat just 32 kilometers from a major railway, close to high-grade iron ore and coal. Beyond minerals, it secured water from the nearby rivers, while a direct railway line provided a path to Kolkata. Jamshedpur succeeded because the landscape provided every necessary input for the industrial system in one place. It is a clear example of geography deciding the viability of a multi-million-dollar enterprise. Once a location is proven to be profitable, a gravitational pull takes over. Other companies begin to move into the same area to take advantage of the existing roads, power lines, and specialized labor. This clustering creates industrial regions. For over a century, these regions, like Eastern North America and Western Europe, were built near coal fields and seaports to facilitate the movement of heavy goods. In modern industries like information technology, the requirements have changed. Instead of coal, these companies cluster in places with a pleasant climate and access to a highly skilled workforce, creating hubs in Silicon Valley and Bangalore. By concentrating in these specific regions, industries reduce their costs and share the benefits of modern infrastructure, making these locations the primary drivers of global production. However, this concentration of industry and people creates a high-stakes environment. When these complex, hazardous systems fail in these densely packed regions, the human impact is immediate and severe. In 1984, the Bhopal gas tragedy demonstrated this risk when a toxic leak from a pesticide plant drifted into the surrounding residential neighborhoods. Thousands died, and those who survived faced lifelong health struggles, ranging from blindness to impaired immune systems. Similarly, in 2003, a gas well blowout in Gaochao, China, killed over 200 people and forced the evacuation of tens of thousands more. In both cases, the proximity of hazardous industrial processes to residential areas turned a technical failure into a disaster. Reducing these risks requires strict planning, separating residential zones from industrial belts, limiting toxic materials stored on site, and upgrading gas and fire warnings. Industries are the engines that transform our resources into the goods we use every day. But as we have seen, their benefits depend on a careful balance